So, ladies and gentlemen, welcome to this panel session of the Awards 2021. In addition to the presentation of all finalists that you will find on the platform in the finalist presentations rooms, this year we have organized some panel discussions with the finalists along the week. And I want to welcome the 3 finalists of the category Project of the Year up to 50 million euros, including renovation. And these 3 finalists are Michael Wren, that will talk about long-term recycled water release. Simon Long, that will talk about relocation of Shenzhen sewage treatment works into Caverns. And Wang Shaoyang about the Dangchaon Danishan emergency shelter project. And so they will have a brief presentation, not the whole presentation that you will find in the platform. And the goal is afterwards to have a discussion on the different topics that are of interest in these projects. And this panel discussion will be co-chaired by Amdi Aydin, ITA Executive Council member, and last but not least, ITA First Vice President. So, Michael, I give you the floor to start with a brief presentation of your project. You're muted.
Thank you very much. Yes, I was muted. Hi, I'm Michael Wren. I was the project manager on the Gold Coast Seaway project. So part of this project was to install a pipeline from the Gold Coast across to South Stradbroke Island. That pipe was 1.4 kilometres long, and it needed to transfer treated water at a rate of over 6,000 litres per second. The initial idea was to have a dredge crossing, was to dredge and lay a pair of HDPE pipes. But obviously there were significant social and environmental issues with that. There were layers of coffee rock here within the dredge profile. So the dredge plume would have impacted over 3 kilometres of this waterway here. There were seasonal nesting grounds for curlews on Carter's Bank. There was an area of seagrass, and all of South Stradbroke Island was a state marine park. So all of that would have been damaged by the dredging. There was also a large community of sailors, fishermen, recreational boat users, and tourism attractions. Sorry, was there a comment? And tourism attractions here on the Gold Coast, and they would have been impacted as well if we had gone with a dredge solution. So together with our client, the City of Gold Coast, John Holland developed a better solution for this pipe crossing, which was tunnelling under the Broadwater. We had some exceptionally good consultants, contractors and suppliers on the project. Our key designers and consultants include WSP, Golder, Bonacci, McMillan Jacobs, Independent Civil Solutions and BAMSA. Our key subcontractors were Bothar and Keller, and our key suppliers were Humes and RPC Iplex. One of the things that we did differently on this project was developing a partnering approach. Initially, we ran some partnering workshops before the construction started, and that allowed everyone on the team to understand the key drivers for our client, City of Gold Coast, and for the project itself. During that workshop, we developed a partnering charter, and that set the expected behaviours. It didn't replace the contract or the subcontract agreements, but it did set a basis for how we communicated and how we made decisions throughout the project. And even when we faced the worst of our challenges, all of the delivery partners were able to work together to successfully complete the works. This was an extremely complex project. We had 2 shafts over 20 metres deep in saturated sands. The drive was 1.4 kilometres through varying ground conditions. And because it was in the Broadwater, there was no economical place to put an intermediate shaft. So we had to do the full 1.4 kilometres in one shot. We certainly had our challenges, but with our partnering approach and really good subbies and consultants, we overcame all of those challenges. Some of those key challenges, saturated sands. We had 2 shafts to build in saturated sands. Where we did the secant piles for the launch shaft, we had issues with significant water ingress into the shaft, and we resolved that through jet grouting around the shaft and increasing our water treatment. Over on South Stradbroke Island, we had a different construction technique. We sank a caisson over there, but again, that hard layer of coffee rock above the soft layers of sand made things quite difficult, and we had some movement and damage to the caisson over there. Golders put together a really great plan to remediate that. So we did some polyurethane injection, more jet grouting, internal steel sleeve, and some annulus grouting. The mixed face tunneling conditions themselves did have quite a bit of an impact. So when we were doing all of our planning, we really focused in on that last section of sand, saturated sand. And both had some really good equipment and really good plans for managing the sand, but the mixed face ground conditions forced the TBM out of allowable survey tolerance. We overcame this because we actually had a product pipe inside the carrier pipe, and we were able to adjust that to get the tolerances we need. The most significant challenge we faced was some significant cracking and crushing to the pipe and the pipe getting stuck. So across the full duration of this drive, we had 45 days of stoppage for investigations and repairs, and that included a single stoppage of 25 days. So that was a real challenging time for us. But we all pulled together. The designers, Bothar and John Holland, resolved that. We developed a steel and epoxy collar design that effectively bypassed that damaged jacking pipe. Despite the challenges, or maybe because of them, this project was a great success. Our specialist consultants, such as WSP, Golder and Bonacci, provided great service and innovative solutions when we needed them the most. Our key subcontractors, Bothar and Keller, they both had excellent equipment, experienced operators, and were able to put in a huge effort to overcome all the challenges and get us across to the other side. Because of the way John Holland delivered these works, and because of our partnering relationship with City of Gold Coast, we were able to negotiate an additional portion of works. And that involved a second pipe jack from the same launch shaft back under a bigger creek to O'Connell Park. And this provided our client, City of Gold Coast, with significant future cost savings by reusing that launch shaft and reusing all of the plant and equipment, staff and workforce that were already mobilized. And this second crossing was a great success. But most importantly, we were able to deliver some great infrastructure for the City of Gold Coast with minimal impacts and many benefits to the community and the environment. Thank you very much.
Thanks a lot.
I'll stop sharing.
Thanks a lot, Michael, for this brief presentation of this project and specifically the approach, but I think it will be one of the topics we will be discussing later on. Let's go to the second project that was in this category of project below 50 million euros, including renovation, with Simon Long, that will present the relocation of Shetland sewage treatment works into Caverns. Please, Simon.
Yeah, let me just share the screen here.
We don't have your screen for the moment.
You okay now? Everyone see the screen now?
No, you have not shared. Nothing is shared for the moment. Yes.
Okay. Okay. Let me start with introducing the projects here. As Oliver just introduced the project here, the title is the relocation of Sha-Tin sewage works to Caverns, and the project client is the Hong Kong Government Drainage Services Department, and AECOM is the consultant. And here, I'm the Chief Resident Engineer. So for those that who do not know the Hong Kong system, Chief Resident Engineer is the consultant supervising the whole project itself here. So the summary here, agenda today is the project overview a little bit, innovation that we adopted in the tunnel works here, sustainability, site safety, and health, one of the very most important focus in this project here. And finally, I will go through the conclusion very briefly here. The project overview. So what I just introduced the client, consultants, and the contractors here, and similar to the previous presenter, we adopted the partnering approach that all these three parties that work together to achieve the common goal here. So what you see in the photos on the right-hand side here is the existing sewage treatment plant, and the whole project, the aim of the whole project is to remove every single facility on the left-hand side of the river and relocate every single tank to the other side of the river, but not exposed to the public inside the cavern here into the Loop or Sand in Hong Kong here. Why Hong Kong need to develop large caverns, and why do we need to do the caverns here? Because if you know, Hong Kong is a very small place. As a pressing need for the Hong Kong government to find land to develop the residential and the recreational land use here. So the whole aim is to the cavern development territory-wide plan formulate. So the study on the long-term strategy for cavern development is the territory-wide cavern master plan, a formulate a policy, develop a systematic relocation program here. So we face a lot of challenge in this project here. This is a very large-scale project, and it lasts for more than 10 years to break up the cavern and build up the upstream drainage and sewage facilities, and also the demolition of the existing sewage treatment plant. And this is a very complexity project itself, because that we have to spend a lot of focus to connect with the interface, sort out the interface with the external project, and also the internal interfacing problem as well. The pioneering project, because this cavern here is the very wide and very large in scale in dimension, about 20 meters high, about 25 meters wide, and this is the tunnel first project here. And future tunnel project is about 32 to 35 meter wide as well. And this is a very complex cavern development, involve a lot of multi-blasting, about 7 to 9 blasts per day in the future. So the conclusion is to uplift the technology adopted in the site supervision for tunnel and the pilot project for the future cavern development in Hong Kong. That's the very brief. Introduction of this project here. Thank you, Oliver. And also innovation in the tunneling as well. Okay, and that's the end. That's the end. Okay, thank you, Oliver.
But your last slide, maybe we will come back to it, because it was also something quite interesting in your project. about
this
the
is the end
United
slide. This is the end of the slide.
Intelligence.
This is the end.
No, but I was saying that the slide, just the one on United Intelligence.
Oh, that one one here, yeah.
Yeah, that one is something that that for discussion as well.
Yeah, you will discuss it. Okay, then later on. Okay. Do you want me to discuss it now?
No, just after. So now we will
Later,
have.
yeah. Okay then. Okay,
can you
then.
stop
Thank you.
sharing? Thanks a lot. So now we have a presentation of Wang Shaoyang about the Dangchaon Danishan Emergency Shelter Project. So please.
Hello, everyone. I'm very happy to report of Dangchaon Danishan Emergency Shelter Project to everyone. At first, let's look at the project overview. The Dangchaon Emergency Shelter Project is positioned as the wartime civil air defense project, which is mainly used as the cave laboratory as the LARA project at the peacetime. The project was started in July 2019 and completed in April 2021 with the total contract amount of RMB 146 million. The construction area of the challenge is more than 24,000 square meters. The main body is a fire-shaped structure composed of one main entrance and one secondary entrance. The total excavation length is 1,150 meters, with many types of tunnel intersection, diverse and change cross sections, complex construction techniques. Control the large scale excavation, we use the tunneling by zero excavation method. We extend the entrance 8 meters from the original design. And here is the tunnel was used as wartime for the defense project, but for the peacetime is used as the cave laboratory for the gravitational wave detection. And for the energy conservation, let's look at the well and the outlet from the small tunnel. And the safe flow of air is used, supplemented by the higher pressure and extraction, so as to solve the ventilation problem in tunnel with the lowest energy consumption. And the drainage, the construction along the run-up slope as far as possible to reduce the unnecessary pumping energy consumption. For the cost-saving utilization of the tunnel ballast, the tunnel ballast, the crushing and the screen and used for the concrete and for the subgrade filler. During the COVID-19, the communication is mostly important, and frequently we take full interaction to understand the owner's need to solve the problem in the process. For example, we're organizing by the owner of the various communication meetings for the health care, for the workforce organization, and also we take out the nucleic acid test on site. That is a guarantee. We finished this work in 22 months. And finally, we wanted to make a summarization and the proposed. The summary is like this: due to the innovative face of difficulties and creating high quality underground projects with new technology and environmental protection, control the cost for the environment, coordinates and cooperate with the social development. So for that kind of underground utilization, we may achieve the green and environmental protection and take out the sustainability of the underground project. So thanks. That's all for the simple introduction of the Danishan Shelter Emergency Project. Thanks.
Thank you very much. So now I will give the floor to Lars and Amdi. Also for the people that are attending this seminar, if you have questions, be free to ask them through the chat, or even though as we are not so many people, just say to the chat and I can give you the floor to ask your question directly to one or several presenters. So Lars, Amdi.
Thank you very much.
Thank you. Yeah, go ahead, Lars.
Yeah, thank you very much to the presenters, and many thanks for submitting your interesting, fascinating projects, and obviously was kind of quite a lot of challenges. Amdi and myself, we both prepared a couple of questions from your earlier presentations, and because it kind of triggered our curiosity, and thus we probably start in the same way as the presentations were going. So we would start first with the Gold Coast with you, Michael. If you mind. And one of the questions, I mean, the project by itself, just for better understanding or as well to the audience, it's not only about this pipe checking tunnel. Where does your line goes further? What is because I assume that there comes another tunnel outside of the island.
Yeah, absolutely. So what we delivered was stage 1 of the long-term plan, and I'll just share my screen again. So
yeah,
let me show this one. Yeah, so
can see, yes.
The long-term plan for the city of Gold Coast is quite a few stages. This was stage 1, which was effectively removing the bottlenecks. There was an existing pipe across here that had been dredged in about 30 years ago. That's not sharing the right screen, is it? Hang on a sec.
No, we see the other view, but that's fine.
Stop share.
Okay.
All right, I'll just talk to it instead then. So yeah, stage 1 of the long-term plan was just to remove the bottlenecks across the Broadwater, and that increased their capacity by about 40%.
Oh.
The full long-term plan has, I think, about 6 stages all up. It won't be fully developed for another 10 years yet, but it increases the capacity by 350%. So there absolutely are some more stages after this one. The next few stages are just connections into the treatment plants. There will be an ocean outfall some point, probably the other side of 2030, an ocean outfall, and then multiple diffusers out to sea there. So one of the constraints that City of Gold Coast has got is they can only discharge on an outgoing tide. And that's to ensure that the outgoing tide takes all of the recycled water out to sea.
Yeah.
Once they get their ocean outfall, they'll be able to pump 24/7. So yeah, it's quite a smart strategic plan by City of Gold Coast, and they've staged it. One of the great things we were able to do was actually bring forward part of the next stage of works. And add it to this stage of works. And what that really helped out City of Gold Coast to do was get under the creek going back towards the treatment plant. So we saved them building an extra launch shaft in probably 5 years' time. Yeah. And it saved the community from having to put up with construction again in another 4 or 5 years' time. So really good outcome.
Okay. Sounds good. So you plan actually another outfall tunnel then going out from this island? Okay.
Yeah, that's right.
Okay.
Yep. Now, yeah, City of Gold Coast procurement plan will have that going back out to tender again. So it's not guaranteed that John Holland will have that, but we've certainly put in some good work on this one. So hopefully we pick up that one as well.
That's good. Now the question is, how deep was this tunnel? I mean, you had 1.4 kilometer of tunneling with pipe checking. I mean, that's quite an outstanding length. That's probably not really the world record, but you're close by. And
Yeah.
how deep was yours? How did you maintain cutter head during the operations? Did you do any compressed air interventions? Can you
Yeah, yep.
a little bit tell us?
Yeah, absolutely. So we were 1.4 kilometers long. The shafts were about 20 meters deep, which meant we had in the deepest part of the Broadwater, we had about 8 meters cover of sand above us. When both our was our specialist subcontractor, and when they got involved, they actually did lower the tunnel alignment slightly to get a little bit more room on top there.
Yeah.
So the face pressures were managed within a very tight range through that sand section. But everybody was quite worried about that sand section at the end, especially the very low cover section. But it turned out to be the easiest section of all. At first we had trouble. It was a mixed face head. When we first got started, there was quite a bit of clay, so it did clog up, and our progress rate wasn't what was expected. The guys did a really good job of getting through that and working their slurry system to try and get through the clay quicker. We did do a hyperbaric intervention, and the cutter wear was actually pretty good. So they did replace a couple of cutters, but mostly it held up really well. The intervention was done in hyperbaric conditions, but we also found an area of slightly more competent material. So we did pick the point where we were going to do the intervention, and then ran that intervention quite successfully. Had obviously the divers on standby. One of the things both did do really well was equipment selection. So they had the hyperbaric chamber ready to go. So they weren't going to take the risk that maybe they didn't, maybe they did. They put it on. They had a really good cleaning system, a bower cleaning system, and that was nice and quiet, and that kept the community quite happy. So yeah, some really good plant selection there.
Okay, perfect. Yeah. Andy, you want to?
Yeah, I want to ask additional questions that we prepared together. In your presentation, Michael, first of all, thank you for your good presentation. You said cost saving. Cost saving means compared to something else, it is cost saving. What was in your feasibility study the other options, and compared to the others, it was the cost saving? And another additional question is, what was the cost in feasibility study and the final, because you had some problems also, the final cost and the initial cost. Can you tell us about this issue a bit, if you don't mind?
I can tell you some of that. Ultimately our client, City of Gold Coast, they ran the feasibility studies, and they've got the full understanding of the long-term plan. So they understand all of the 6 stages. We were brought on to tender and then deliver stage 1, which was in particular the Broadwater crossing. As that changed from a dredge solution to a pipe jack solution, the client also started looking at their future stages and how they were going to get across that creek. So originally they weren't sure if they were going to thrust bore under the creek. There wasn't a lot of room on the other side. They weren't sure if they were just going to coffer dam and dig, but the community wouldn't have been happy. There's quite a few marinas up that creek. So it was a bit of a problem for the client, which they probably in the end would have gone to another pipe jack solution, which didn't have to be delivered for the next 5 years. But the issue then would have been, we've just dug up this park and we've made the community mad for a year, 18 months. We go away for 5 years and then come back and do it all again. So from a community point of view, it would have been a real impost on the community. From a cost point of view, there would have been the cost of the shaft all over again. And the tie-ins would have been really quite difficult in that in the park. It wasn't a very large park. The site was quite constrained. So the cost of another shaft, and when we presented the cost to do it in 5 years versus the cost to do it now, there was a good saving to the client.
Okay.
And sorry, what was the second part of that question?
Yeah, the second part was the
cost compared to the original
cost compared to the others. Yeah.
The cost to the client was exactly as per their cost plan. Despite all the challenges that we had, there was not really a latent condition claim. There was no additional cost to the client. In terms of contractors' cost and subcontractors' cost, it was higher. Yes, we managed to not wear quite so much pain because of the variation back the other way. So although we still felt pain, both us and our subcontractor felt a bit of pain on this project, it wasn't as bad because the second drive back to O'Connell Park went really, really well.
Mm-hmm. Okay. Thank you.
Okay.
May I ask a question that could make the transition with the other presenters? In all your presentations, all of three of yours, you highlighted the cooperation between the contractors, engineers, and the owners. And it is, I think, something very important in our business. That sometimes it's difficult, and maybe more and more difficult with owners that may not have all the that are newcomers in the tunneling business. You, Michael, but also Simon or Wong, how do you see this cooperation between the engineering contractors and owners going to be developing?
Yeah, I found it exceptionally good on this project. City of Gold Coast is one of the best clients I've ever worked with. And the partnering approach we had during that first workshop, I remember somebody said, this partnering thing, it's not about when things go well, it's about when things go badly. How are you going to react when things go badly? Are you going to throw the contract at us, bang the table and make it all of our problem? Or are we going to work together for a solution? And even though things went badly, we did. We all worked together and got there and delivered what we said we were going to deliver. Yeah.
Simon?
I think in the old days that different parties played very distinct different role, but nowadays that collaboration under the partnering spirit is a buzzword of the success, because every different kind of parties can mingle up together and with the vision of the common goal, and everybody share the same visions to achieve the project. And if someone failed to achieve something, the other party can just step up and show that deficiency. And that's the collaboration amongst all parties. And to achieve this, that some basic ground rules that all three parties have to bear that in mind. That's the mutual trust and cooperation. Everyone that have to trust each other and not challenging each other itself. So if something failed, that have to bring up low blame culture. No one can blame any other as well. So everybody sharing the same view. So I support this collaboration under the partnering spirit, and that's the success of our project in Hong Kong here. And that I really have to promote this spirit as well to other projects. Okay.
Mr. Wang, on your project, the cooperation with the owner.
Yep. So we keep the close and frequently communication with the owner to fully listen to understood its user requirements and insisted the continued improvement in the process of the design and the construction. And so to finally realize the owner's construction purpose and reduce the variance inconvenience during the operation life cycle. So meanwhile, in order to meeting the total duration and unfavorable environment of COVID-19 in her country or all over the world, we actively organize and solve the construction by means of on-site and video conference with the owner, with the designer, with the all of the supervisors and the governments, and because the site is on campus, so we opened the green channels for our works to enter the campus, timely make the recordation in the campus and handling temporary campus entry passports for participated per personnel and vehicles, and organize the medical personnel to take out the nucleic acid test at the tunnel site. So depends all of the measurements, we achieved the same the target. We finished this project in 22 months. It's not prolong any of the construction period. So that is the experience that we want to share during the COVID-19 pandemic. Thanks.
Olivier, you?
No, go ahead, Lars.
One question would be probably, how do you three projects, how do you see let's say the impact of new technology, BIM, and so on, information exchange? Do you see that as an add-on to the partnering, or do you see that more like, okay, to the ones who have the data and who have not the data? Or do you see, what is your experience? Was it more like let's say, the basis for or an enhancement for partnering, or was this something irrelevant for your project?
Simon?
Who wants to jump in first?
Yes, technology is a core value of the project in here and also Hong Kong, because the Hong Kong government promoted what we call in Hong Kong here is the construction 2.0. One of the reasons is the resources problem is going down and budget overrun, delay, and problem things like that. That we have to think of ways to improve the productivities. So one of the method is to promote it and adopt the innovation technology that we used in the project here, especially the tunneling project here. We collaborate with the client and the contractor with Internet of Things, the platform that over the life cycle of the project, we generate a lot of data. And in the old days, all this data is drained away, that you never used it again for the project or even the project of myself. But now that we use the technology to innovate a platform to connect all the data that we generated over this project life cycle here, analysis it, and we used it for other projects as well, and for calculations of this project, as well as to pass it on to other projects to use it amongst the contractor, consultant, and the client as well. So BIM, modeling, that helps a lot, that's undoubtable. And also robotic unmanned vehicle that we used in this project for entering the tunnel. Before the short file goes into the tunnel, that we use a robotic to take the photogrammetry record and or to take over the human beings' unsafe circumstances. That's so I think the innovation technology can really bring about the collaboration amongst all these parties here. Okay, thank you.
Very good. Wang, you have an opinion there? Do you did you feel some impact or from let's say from BIM technology or from your data management there, that it helps you in the cooperation, or?
Yeah, definitely. The data that were mentioned, that we share the platform, we use the platform to share the data amongst the contractor, collaborate with the client as well. And BIM, definitely, because it helps to simulate the construction method and the sustainability and improve the method of working, share the data, share the method with the contractor, or even the frontline worker with BIM. Usually, the people just use a 2D drawing. It's really find it very hard to understand the whole process of very complicated process. But now you use BIM, that is an animation to simulate the whole process of the construction. It helps a lot in terms of safety, progress, and the environmental management as well.
Thank you, Simon. Thanks, Simon. Meng, you have a position there. Do you want to share your thoughts on this topic, or Meng?
Yeah.
Can you?
We didn't use the BIM for this project, just like the Simon just said. But we use because now we use like some kind of information platform like the WeChat and some like.
Sorry, it's very difficult to understand. Can you get a little bit closer to the microphone? I think, or it's very difficult to understand you. Sorry. Hello?
No, we
lost.
Yeah.
Oh, we lost you.
Wang?
That's not what I attempted to do.
We lost you. We need you.
No, he doesn't. Is
okay. Well, maybe
Michael
Yeah, I'll jump in there if you don't mind. So yeah,
Michael,
like Simon said, there's a lot of data produced on these jobs, a huge amount of data, and we had a couple of different platforms to try to manage it, and I think we've done better. I think it is improving, but I can see the progression from projects I've done in the past to this one, and the next ones I see we're improving even more. And I do think it's important, especially in the collaboration side of things. In accordance with the contract, the client can ask us for any and all records, and we can do the same for our subcontractors. So it's not like any of this data is not to be shared. It's just difficult to be shared unless you've got a good platform to do that. And I think we're moving in the right direction, but definitely got a ways to go.
Okay. One thing is probably what we had here or on our side is then to have.
Wang is back. Yeah, perhaps you want to say something. Wang is back.
So I'm sorry. So we didn't use the BIM to take out the construction, but we shared the design with the designer and the owner and our construction, all of the contractors through the data shares information system, just like the Baidu disk. And all of the body could see all of the documents designed or the construction documents in one platform to collect the data. And also we have a very good health system. We may share all of the health card with the different participators.
Yeah.
So that would be to prevent any of the potential patients enter our work zone. So there is no any of the contaminated case in our construction or the process.
Okay. Very good. Thank you. Olivier, you look at
one of the specificity of Hong Kong, and that has always been, as it is a very small area, very dense area, one of the specificity is the reuse of underground space. So and it's something that needs to be thought in all the projects that we are building We are building underground projects that, of course, will last long, and we do it that their life cycle is 100, 120 years and so on. But we might also think of what would be the future of these projects, of these underground infrastructures. I know that's something that is in Hong Kong, something developed. Simon, can you tell us a little bit more about that?
You rightly point out that Hong Kong is a very small place. Everyone is squashed in a very houses or places here. So that's a pressing need. Very urgent to find more land for more space, that not only the residential and also the industrial and the recreational land use as well. That's becomes very urgent now. So what I think in the future, what can be housed in the cavern? Not everything that we wanted to house in the cavern. Only the like switchman plants and any unsightly operation, like for example, treatment plant, and not welcomed by the resident. All those facilities, I think we can house it in the cavern, because if you know Hong Kong well, Hong Kong is a very hilly terrain everywhere, a lot of mountain. So apart from people use that mountain for hiking, why not just break up a hole and house everything inside the cabin here? But that, of course, that's a downside, because to break up the cabin is a lot more expensive than you develop a land over reclamation, things like that. It's more expensive. But I think if you use the sewage treatment plant, my project as examples, then not only that you can free up some land for future use, that you can put the sewage treatment plant, and in future 10 years time, the older problem will be solved. Everybody live nearby, you won't suffer the older problem. You cannot smell the sewage treatment, the smell anymore. So if we along this line of thinking here, all these on-site operation facilities that housed in the cavern, and that's a very big market to along this way of thinking. So I think it's very important to, this is the first project of cavern in Hong Kong. So if we do it well, and if we generate more data for future use, that the other project in next generation or next generation, then you can use this data or my experience here in this project and develop more innovative and develop more sustainable cavern projects in Hong Kong, or maybe other places in Asia or other places in the world as well. That's what my vision in the future here.
The odor, Simon, you touched the topic of the odor. I had, the question was, one of mine was, well, it's not disappearing, the odor. So what do you do with that? Are you filtering it out before you get it through? You must have an exhaust ventilation line.
If you look at my PowerPoint, the existing sewage treatment plant is a very 20 hectares land, and in between there's a flyover. There's a flyover in between that sewage treatment plant, existing one. Every day when I drive to my office from home, and everybody drive along this flyover, what they need to do is they turn off the filter in the car. Otherwise, that you can smell this. You can smell the odor, coming through the car here. So 10 years time, if we move this sewage treatment plant in the cavern, and that's the natural shelter inside this mountain here. All the smell contained in the cavern there, with the oxidized activated carbon to filter out that smell before they discharge it out. That's the very good technology, Very important. Very important as well. Natural shelter.
That's a worldwide problem.
Can I ask a question to Simon?
Yeah.
Simon, thank you for your perfect presentation. We have learned that Hong Kong has a very good rock quality for cover. You gave us a lot of information. You collected also a lot of data. You used robotic monitoring system, a lot of things, the payments and blockchain payment system, everything is good. But for pure tunnel people, you didn't give us any information about the excavation. Did you, which problem did you face? For example, what is the area of single blasting and what is the total excavation area in this large cavern? Can you give us some data information about this issue, please?
The project now, first stage is the access tunnel, right? The blasting phase, one whole phase is a horseshoe shape and 25-meter wide, 20-meter high. So when we do the blasting, I can't do that in one go. I have to divide it up into 3 to 4 blasts for this shape here. So that's the dimension of the tunnel, first of all. But in future, the tunnel, the cavern will be much bigger, 32, 35-meter wide. But now I'm talking about the access tunnel first. So another figure very important, that is another challenge that we face in Hong Kong here, is the disposal of the rock. Every day that we generated more than 1,000 or sometimes 1,200 cubic meter rock that we generated in Hong Kong here for one blast. So another challenge is we have to disposal that amount of rock from the cavern to disposal ground. That we have to travel more than 1,000 vehicle truck per day, along the road here. And you know that Hong Kong is a very congested area. It's already everywhere is the traffic jam. We can't just impose the more traffic jam to the already traffic jammed road. So how can we, transporting this 1,000 vehicle truck per day is another challenge to us. So you also mentioned about the, well, first of all, that's the dimension of the figures of the project and robotic. And let me elaborate a little bit more why and how we use this robotic here, because safety is a very important issue in Hong Kong and in the world as well. So every time after the blasting in Hong Kong, we use a short fire. A human being goes into the tunnel to check if there's any misfire. But now we use a robotic with the 5G network in Hong Kong here, transmitting the data and image into the tunnel to the mobile phone here. So what we do every day is just see the mobile phone. Is there any misfire? Is there any rock wedges falling opportunity or risk, things like that, that we use the mobile phone just looking at it inside the office that actually minimize the risk of the human being going into the dangerous zone in this very dangerous time straight after the blasting as well. And also you asked about the blockchain, why we used it and how we used it. The blockchain is that is a very immutable system. No one can change it, and very safe and traceable record here. Because in Hong Kong here, to qualify, to check a payment, to qualify a subcontractor payment or main contractor payment, there's a lot of checking in Hong Kong here. To pay $1 Hong Kong dollars to the contractor and pay main contractor to pay that $1 to the subcontractor, there's a lot of procedure, a lot of works to prove that, to substantiate to me. So for those checking here, that we made a smart contract for the blockchain system, automatically using that smart contract to check that qualification. So what we need to do is to subcontractor key in the data. So what I need to do is just press the button, it's automatically go through those smart contract. It's checked everything for me already. And all this 10 years project with a blockchain system, I can, in 10 years time later, I can trace that 10 years ago data accurately and very quickly. So this is a very good system to have the blockchain system, especially this tunnel cavern project lasts for more than 10 years. That's a very good system that we really have to promote it as well. Okay.
Thank you.
Thank you very much. As we are coming to the end, I've got a question from one of the attendees. Even though it will not change anything as the panel of judges have already voted, but can you, each of you, in one sentence, say why your project should win the award? Who wants to start? This difficult question.
Yeah, I'll start if you like, Olivia. So on the Gold Coast Seaway project, we demonstrated to the client that we could overcome their environmental and community problems. And then despite significant challenges, we overcame them and delivered some great infrastructure with some really outstanding environmental and social outcomes.
Thank you, Michael. Simon?
If you ask me to use one sentence to describe the project, I would say that I finished the project and complete this project not only within time and within budget. We also innovate a lot of works to complete this project successfully, serving the community, and also created a sustainable world to the communities around this Sha Tin and Hong Kong here. And also the sustainability measures and innovation that we innovate over this project here. We already paved the way for future cavern project in Hong Kong and also Asia, or maybe the world as well. Thank you.
Thanks. Mr. Wong?
The reason is that as a civil air defense working for emergency shelter, the project has a good advantage to use as a scientific research laboratory of LIRA project. It used to detect the gravitational waves from the sky. It can also be converted to the wartime civil air defense within 15 days before the airstrike, which fully demonstrated the superiority of the underground space utilization and reuse. That is the reason I think we may win this prize. So thanks.
Okay, so thank you to all of you. We will have a result of the winner on Thursday afternoon. So you will all three receive an email to participate in the award ceremony. And of course, the winner will be allowed to say some words at this occasion. I want to thank all of you. I want to thank Amdi and Lars for sharing this session. We have another live session this afternoon on the category Technical Innovation. So I invite everybody to be there, and thank you again, and thank you for all the efforts you've done in making entries and making the recorded presentation and this presentation and on this live session. So thanks a lot to everybody.
Thank you from our side.
Thank you.